Hello everyone. Today is the day 16 of our challenge, doing 30 deep learning projects in 30 days. So we yesterday on day 15 we what we did, we prepare a simple time series data set for to train our RNN model. So what we have left for today is to first understand what RNN model is and how it works, and then what we are going to use the data set that we had prepared yesterday to build the model, and do temperature forecasting. Also see how the model is performing and everything. So let's continue where we have left yesterday. So I'm going to use the same context window of ChatGPT. I'll say, hey, it is day 16, and today, what are we going to do? We are going to build a basic animal from the data we have prepared yesterday. So yes, I have uh, submitted my prompt, but let's wait for the chat gpt to generate the response. Once it is done, I'm going to read and see what all I need to ask from chat gpt. As I've told you, we have not yet explored and how this, what is this RNN model, and how does this work, model work. So we are yet to study and read a little about that. So it says, yes, let's proceed with day 16 by building a basic RNN model for sequence prediction. We'll use the data prepared yesterday, which we already transformed into sliding windows. Yes, we are going to use the data that we have prepared yesterday. So I would recommend to go and watch that video. So it says we will be importing the libraries. I'll see what all libraries are new today, and then build the model and compile the model, train the model, and look at the performance. Before I code, that's what I'm asking from ChatGPT. Before I code, can you please explain what RN model is and how it works in simple, easy language, without complicating it? Okay, it has generated the response. So let's go and read a little about what it says. So let's understand what RNN is. An RNN is a type of neural network designed to work with sequential data. Okay, so it is a type of neural network. Good to know because we have been studying neural networks in this entire challenge. It is good to study to work with the sequential data like time series, text, or speech. Why? How do we know our data is sequential data? First, because we looked at the data yesterday. We had temperature for each day since 1988, right? If we look at the data, so that is a time series data. So we have a time series data, sequential data like time series data, text data, speech data. Then RNN, this type of neural network is good. Unlike other neural networks, RNN have a special ability. They can remember information from previous step in a sequence. This makes them perfect for tasks where context matters. Okay, why is it important? Because RNN are good at remembering the information from the previous steps in a sequence. Okay, think of RNNs as having a memory that allows them to use past information to make predictions about the future. Okay, so RNN uses past memory, that is past steps, to predict the future. How does this work? So I do understand. I don't have to go and read the analogy. So yes, because it is itself is pretty easily explained. Now we understand how does an RNN work. So how does an RNN work is so let's break it down in steps. First step is sequence as input. And RNN takes it in a sequence of data. For example, if you want to predict the temperature tomorrow, we can use the temperature of from the past 10 days. Okay, the sequence is going to be temperature of day 1, day 2, day 3, day 4, day 5, day 6, day 7 up to day 10. Then we process one step at a time, and RNN processes the sequence one value at a time. Okay. When it gets the temperature for day one, it produces an output, and because but it also keeps some information about what it has learned. Okay. Then it takes day two along with the information from the day one to produce a new output, and so on. So it uses current day and produces output related to the next day, and also it also sees what it has learned, so it keeps a track of that also. Then processing one step at a time, it remembers the past. RNNs have something called hidden states. You can think of this hidden state as a memory. At each step the RNN updates this memory. This means that every time the RNN looks at a new value, it remembers what has happened in the previous steps. So okay, so it remembers what has happened in the previous steps, that this is what it was keeping from the step 2. Now it makes prediction. Step number 4 is that it makes prediction through the entire sequence. After going through the entire sequence, RNN uses all the information to make a prediction. For instance, for the temperature day 111. So the key feature is that it first it prepares the sequence. It takes the sequence as the input. Then from each sequence it takes one input at a time. It processes one input at a time, and it also learns from that input, and then it remembers the from the hidden states. It remembers that what has happened in the previous step, and then from all this information it predicts for the temperature or the value for the future. The name recurrent comes from, so the here the full form is recurrent neural network. They did not mention it, right? No, nowhere it is. Oh, it was mentioned. So RNN stands for recurrent neural network. The name recurrent comes from the idea that RNN keeps doing the same thing over and over for each value in the sequence, and it remembers what it did before. Okay, so recurrent here, recurrent neural network here, it means that it keeps on doing the same thing again and again, and remembers what it has done in the previous step or before, and it uses that information that it had saved in the memory to predict the temperature for the future, for the target, let's say for the day 11. So it is like following a recipe and remembering the previous step while cooking, and cooking each new step. Okay. Yes. So let's read a little more. It says that visual example would be, let's say we want to use an RNN to predict temperatures. Okay. The RNN looks at day one's temperature. Okay. It stores some information about day one. Then it looks at the day two. Then it remembers the information from day one, also stores the information about day two. Then it continues till the day 10 while updating the memory at each step. Okay. Finally, after seeing all the day 10, it predicts the temperature for day 11. Okay. How does this memory work? How does this hidden state that we had read in the step 3 work? It is like a small note that RNN keeps with it. Each time it sees a new part of the sequence, it updates its note. This note helps the RNN keeps track of things like trends or patterns in the data. Okay. For example, if the temperature has been gradually increasing, the RNN remembers this trend and is more likely to predict the higher value for the next. Okay, it remembers the trend. Why are RNN useful? For the time series prediction that we saw earlier, and text analysis. RNNs are useful for time series prediction because they are great at predicting future values based on the past data, like stock prices, weather. Okay, stock prices also RNNs are good. Okay, weather also that we are using. And then for text analysis, RNNs are used in language model because they can remember the context of a sequence, which helps understanding meaning. Okay, nice. So possibly ChatGPT might also be using text analysis, right? Yeah. So RNNs are really good at text analysis also. That is good to know. Then shortcomings of simple RNNs. Simple RNNs are good at remembering short sequences but often struggle with longer sequences because they forget earlier information after a while. This happens with that chat GPT, you know, right? But yeah, they struggle with short memory. They tend to forget the earlier information. More advanced versions like LSTMs and GRUs are designed to overcome these limitations by helping the RNN remember important things for a longer period of time. That's what we are going to do on day 17, 18, I guess, and 19, 20, and 21. Is that there is a shortcoming of RNN is that it does not remember the information for a longer period of time. For a longer sequence, RNN might not be a good choice. For a situation where we need to remember the information for a longer period of time, LSTMs and GRUs are a better option. Okay. So the summary is that RNN stands for recurrent neural network. They're designed to work with the sequence of data. They do good because they work by remembering the past while making the prediction about the future. Good. Think of them like reading a book. Each new sentence makes more sense if you remember the previous one. Okay, yes. So it is like if I know the context, I'll be able to understand the situation better. That's how I can take the RNNs as. So they are useful in any situation where understanding of order of the data points is important, like forecasting temperatures, understanding language, or predicting stock trends. But they do not work good when we want to remember the information for a longer period of time. For that, we have other advanced models like LSTMs and GRUs. That is not mentioned in the summary though. So it is pretty easy explanation. It is a recurrent neural network that is really good, that works really good for sequential data types like time series text analysis, because of its functioning of remembering the past, and based on that evaluate the future. And then it performs these many steps, and then for a longer period of time it does not work that well, so we will be using LSTMs and GRUs. So we can do what we can. I understand enough about RNNs to start with the coding today. So I'll start. I'll see what all I have to import. TensorFlow as I have already imported. Panda I have already imported. NumPy I have already imported. Sequential, yes. This I have to import. So I'll import from TensorFlow Keras models. Import sequential from TensorFlow Keras layers. What layers do we want to import? Simple RNN and dense layer. Dense we have used it like 100 times. So yes, and then this library we have already imported. So let's use this. I'm not going to print this. We have prepared the data already. So what to do? Yes, define the RNN model. Let's define the RNN model. Define the RNN model. Okay, we'll do what model? Sequential model. Okay, and what layers do we want to add? We want to simple add a RNN layer. Segment we have created. So let's read a little about these layers first, the code first, and then I'm going to code it up. So we'll add a layer with these information, a simple RNN layer with 50 units, which means the number of hidden units or neurons in the RNN layer, which controls the model's capacity. Okay, the number of hidden units or neurons are 50. Activation is 10h. When we use 10h activation, which is 10h activation is commonly used in RNNs. Let me visualize it a little. Um if you remember, when we studied about all the activation functions, we did study about the 10h. So we know how it is, but if you don't know, I would recommend you to go and read a little about this day 13 problem, from the tech journal itself, or you can go and watch the video. So it is a type of activation function used in neural network that maps input values to a range of -1 to 1. Okay, it is a hyperbolic in nature. So yeah, we are using 10h activation. Then the input shape we have taken from the input data set. Then we add the output layer to predict the to of one unit to output the next temperature value, and then we'll print the model summary. Let's add it. So model dot add simple RNN layer, not like this, simple RNN layer. Here we are going to add the units are going to be 10, and the activation, how many units? 50, not 10, 50 neurons. Activation function is going to be 10h, and the input shape, right? Not this one. Input shape is going to be x underscore train dot shape 1, okay, and 1. That's 8. It sounds good. Then we add the output layer of one dense layer to output the temperature value, and then we will print the summary of the model. Simple and sweet model. Then we compile the model. I'm using Adam optimizer. We already know how it works and why we are using it. Then we are using mean squared error because it is suitable for regression problems. Here we predict a continuous values. Okay, it is a regression type problem because we are predicting a value as output. So when we are predicting a value, our MSE, mean squared error, is a good choice for measuring the loss while the model is compiling or being trained. And for the metrics, we are using mean square error. For the classification type problem, we have been using, if you remember, we have been using accuracy, but here means absolute error. For the regression type problem is good to go ahead with. So we'll go compile the, let me do what, let me minimize this, take it at the center, yes, and then start coding again. Compile the model. Here I mentioned model dot compile. Here I mentioned the arguments. The optimizer is going to be Adam. The loss is going to be mean square error, and then the matrix is going to be what mean absolute error, MSE ME. Okay, sorry, this should be passed as it is. This should be passed in the form of vector. uh, that's it. Now we train the model. And model dot fit, what all we mentioned that the train dataset. Okay, the validation dataset, we are going to use this validation dataset. And we how many epochs we want to run? We want to run 20 epochs. And we want to see it, the information it while it is training? Yes. And let's train it on the train dataset. Validation data is validation dataset. Epochs are 10 epochs. Verbose is 1. Yes, I want to see the training information on the terminal. Then we want to evaluate the model. So we will evaluate the model and look at the loss and the ME by using the evaluate function on the test dataset, and then we will see the test loss and the mean absolute error. So loss and mean absolute error, correct? Mean absolute error of the model on the test data. Evaluate on the test dataset, and we will print loss, the loss on test, loss value on test data test data set is here. Yes, here we mention loss, and then we mention the mean absolute error on test data set is mean absolute error. We will see how the model is performing by these two values, and then we are going to plot the history. What are we going to plot? We are simply going to plot the loss. Yes, let's do what? Visualize the loss. So we'll do what? We will do what? We have not stored the history while the model was training, so let's store it in the history keyword, history variable. Now convert it into a data frame. So without converting into the data frame also we can do that. So let's plot it. First define the figure size is going to be 10 is to 6. Is it good? Then plot so we plot history dot history of loss, and the label is training loss, right? And it is loss are we calculating using mean squared error. You can see it here when we were compiling the model. Then we plot the history the loss of the validation data. Validation loss label is validation loss of the means, the that means the mean squared error. Then we plot the x label is going to be epochs, the the y label is going to be the loss, correct? Sorry, loss or the mean squared error. Mean squared error. Then the title will be training and validation loss. Title will be, sorry, training and I had the same typo, training and validation loss. Then we use the legend function to see the lines, as in which line represents what. And then we are done with the problem. So let's do what? Let's run it, not run this code. Today's code was pretty easy because we have already done the heavy lifting yesterday by preparing the data, something new that we had learned yesterday. So the model looks like this, and we have good number of errors. So let's go at line number 98. Here the 98 line number is this. Model add, what did we add? Okay, dense layer with one neuron. Okay, I have an error, correct? So let's clear this and run it again, and close it. It is training pretty fast, and the loss looks like this. There is sharp decrease in the, so the training loss looks is in the blue color, and the validation loss is in the orange color. So the loss quickly drops at epoch first, and then it is gradually decreasing, and same with the, there is steadiness and the gradual decrease in the validation. So the model is performing really good. So I'll take the screenshot that I can use in the tech progress post. So the loss looks like very minute. See, the loss is looking very minute, so the model is performing really good, and the mean absolute error is also very less. So it is really good to see that how the model is performing. So yes, the model's performance is really good. Let's do what? Let's commit the code. They commit minus m, add RNN, uh, build, this is for day 15, build and train RNN model on day 15, and then push it to the main branch. Let's go and look at the code. This is what we have pushed. Yes. So, yep, we are almost done with the code. Yep, the problem for today is we have explored RNN and coded a little simple model into that to predict the temperature. So, yep, we'll come back tomorrow and look at the LSTM model, which is kind of an advanced model on the top of RNN. So, yes, thank you very much.